Nice.
All sorts of fun things. Let's get this running on TikTok. We're live. Cool, and then let me make sure that this thing's running. I'm experimenting. Oh, it is running. Okay, sick. Nice. Okay, cool. So I'm going to say, welcome. Welcome, YouTube. Did that show up in my chat? Oh, wait, I gotta detect it. One sec. Select life sources. And then we need TikTok to also activate. What was I curious? Like, where's the Tiki Talkies?
Wait,
Where'd
you
they
also
go?
do Sunday office hour also?
I will, not this Sunday because I'm in Chicago, but I will for future Sundays, if that makes sense.
Oh, okay.
Or, okay, maybe this works actually. Wait, let's just do the standard way. One sec. Let me see if this works actually. I'm curious. Oh, TikTok WebSocket. Oh, I don't think that's gonna work. Sorry. Check standard. I'm just like curious. Dude, where's my session? There's my session. Okay, but see, this is not my stream. This is not my stream. One sec. Let me fix this.
I don't understand why sine 30 is 1/2.
Oh, why it's opposite of our hypotenuse?
Yes, why is sine 30 is half?
One sec. Let me. Oh, I need to verify, dude. What the hell? YouTube. TikTok. Okay, cool. Dude, how many times I gotta drag the puzzle piece? Oh my god, this is annoying. Okay, whatever. I'm gonna watch my TikTok chat from down here then. I would have hoped it would just work. But it's not working. Fine. Okay. So what we're gonna do here, Jaden, is I've actually written a kind of like a chapter on trig stuff, which I think is like what I call like trig essentials. Like the essential trig that you need to know in order to do like physics. So let's go find it. Here we go. Supplemental life sciences. Cool. Trig essentials. I agree with this. Also, why did my TikTok meter go away? I don't know what's going on. It's all the OBS 12 stuff. Okay. So we know about the Pythagorean theorem, right, Jaden? We understand that one?
Yeah. Yes.
Cool. Let's talk about sine and cosine and like how they work. Okay. So let me get all the trig functions real quick. Here we go. These are the ones we need to know. We're gonna pull these in. Okay. And then let me pull this. Da-na-na-da. And then... Cool. And then let's do an example question. I think an example question would be good. Yeah. And this is where this comes from a lot of times. Yeah. Here, and we'll do this one as like a question. Okay. All right. So, Jaden. Here are the definitions for sine, cosine, tangent, and how they relate to like the sides of a triangle. Okay. So, first of all, these have to be right triangles. What do you know about right triangles?
Pythagoras.
90 degrees, right? You have to have at least one angle that's 90 degrees, and that is right here, this one, right? This is the 90-degree angle, okay?
Yeah.
Now, it always matters what angle you're looking at, okay? So, for instance, if I'm looking at this angle, right, the one right here, the side that is opposite to that angle is literally the one that's opposite of it. Do you see how...
shooting a missile.
Pardon?
Just like shooting a missile.
Good, like shooting a missile, exactly, right, yeah. If you shoot a missile from here, right, like what side do you hit, right? You hit this side, yeah? So that's why that's called the opposite side of a triangle, right? And then the adjacent, you could kind of think about like it's the side you would like miss if you didn't have a missile that was strong enough, right? If you didn't have enough like I don't know, rocket fuel, your missile would probably like hit here, right?
Yeah.
So this is the adjacent side. The hypotenuse is always the longest side. And I tend to call this kind of like the diagonal side, right? Do you see how this is? Usually when your triangles are being drawn, the two, they call these the legs. The legs will be like left, right, and up, down. And the hypotenuse will usually be diagonal. But don't always trust that. The other thing you can know is that the hypotenuse is always the side that is opposite of the 90-degree angle. See, this is the 90-degree angle. Yep, good. Okay, perfect. All right, so once you know the sides of, once you know like the labels, what's up, Umcar? Once you know the labels for the sides of your triangles, the next thing you're going to want to do is figure out which side you have and which side you're looking for. So, for instance, let's just pull up like a random one. Let me see, like right triangle, let's say side angle, one side missing. I can just like find a diagram of this. Sure. Yeah, here we go. Perfect. Love this. Awesome. Let's do this.
Okay.
Okay. So in this case, Jaden, right? We're given this triangle.
Yeah.
And I'm asked to figure out what this side is, right? Like we're like, okay, what is this? What is X? Find the X, right? Okay. So good. That's
adjacent.
Good. This is the opposite. Very good, Jaden. This is the opposite. This is the adjacent. Always label like what the sides are that you have and what you're looking for. I'm looking for the opposite. I'm given the adjacent. Because it's opposite and adjacent, I know I want to use tangent. Okay?
Oh, so it's like which one is opposite and adjacent, and then which one formula to use?
Exactly. Well, you got to look at like what sides you're given. We'll do another example where you're given different sides. So in this case, you were given the opposite and the adjacent. So we're going to use tangent, right? So that means that tangent of my angle, and what's the angle here? What's the value of that?
40 degrees.
40 degrees, nice. Exactly. So we're going to say, cool, tangent of 40 degrees is equal to the opposite side, which is what? We don't know what
X.
the opposite is, right? It's X. Good. Okay,
Yeah.
X. What's the adjacent?
15.
15. Excellent, dude. Okay. Do you see how we can now solve for X?
Yes.
How can we do that?
15 times tangent 40.
Good. Yeah, multiply by 15. Jack Johnson says, this shit mad easy. Well, give me something harder, Jack, dude. Shut up or nut up, dude. What do you got? You got a harder question for me to go through? Please. Please submit it. I would love to do it. Multiply by 15. Good. And so now you get X is equal to 15 tan 40. You did this in second grade in India? Wow. That's special, dude. Nice. One sec. I think my chat's going through twice. Let me fix. Sorry. Let me fix my. Let me fix this. Okay, cool. Maybe it should work. Okay. All right, cool. So now you're done, right? So now we can use a calculator to go figure out what that is, because tangent of 40 we can't really do in our head. If it was like 30 or like 60 or I don't know, like 45, we could. So in this case, we just pull out our calculator. Yeah, you totally can. Yeah, you can totally. Yeah, Steve, bro. Exactly, yeah. So there's a website down there, Steve. Do you see that? www.actualdiscord.com/submit. If you have any sort of math question you want me to do live on the stream, just submit it there, and I'll do it. Or I'll try to do it. I mean, be nice to me. Don't give me, I don't know, like Fermat's last theorem or some shit. It should be something that you kind of, like, want to know. Or, I do calculus. Yeah, 100% I do calculus, yeah. Also, you need to make sure you're in degree mode here. Do you see here, Jaden, how you can be in like radian or degree mode?
Yep.
Yeah, make sure you're in degree mode because we're dealing with 40 degrees. So then I do this, and then I get an answer. Cool, 12.59, okay?
Because it's rounding up. 6 is larger, so it's 12.59.
Exactly. 6 is larger than 5. We're going to round the 8 up to a 9. Okay, cool. Perfect. Okay, now, but here's a good question, Jaden. What if I wanted you to tell me what this third missing side is? How would I figure that out?
Oh.
Yeah.
I have one length, I have another length. I need to find the hypotenuse. What
Good,
should I
you-
use? Pythagoras.
You can use you can totally use the Pythagoras theorem. That is a totally valid way to do that as well. And so I tell this to students, you actually have a couple options, right? So yes,
One
you
use.
Or what
use the Pythagoras.
yeah, let's use
Second way,
Pythagoras.
you use trigonometry.
You can use trig again. Yeah, watch. Okay, so let's use Pythagoras. So using Pythagoras, we know this squared plus this squared equals whatever this side squared is. And sorry, this 15 is somewhere else. Let me move this over. This is 9. Right?
Oh.
Ugh. Wait, sorry. Let me move this. Move you away. Cool. Let's get rid of this. Get rid of this. This is also the hypotenuse, yeah. I definitely do physics. I have a PhD in physics. I would love to help you with physics. Please submit me. Please, for the love of Christ, give me a physics question. Okay. But I love math, too. Math is great. Okay. So we're going to do 15 squared plus 12.59 squared. And then that's going to equal to the hypotenuse squared, right?
Yep.
What's something I can't do? I don't know. I can't go to sleep at a regular hour, apparently. No. I'm not very good at getting girls to say yes to dinner dates. I don't know. They want like coffee or something first, but that's like bullshit. Okay, so now let's do this first. Okay, so 15 squared. Hell yeah, trig baby. Yeah, fuck yeah. So 15 squared plus you're gonna give me some, Jack? Nice, dude. Hit me, dude. Plus that squared. So that's gonna give me 383.42.
83.42.
That's the hypotenuse squared. That's the hypotenuse squared. Good, square root it. Right, square root both sides. And what do we get? 19.58.
19.58.
Okay, now let's verify that that's true, because we can do something else. Ryan says, what's the difference between a derivative and an integral? Derivative is the slope. Integral is the area of a curve. Or like area under a curve is what I would say. Okay. Everything, mate. They are opposites. But they are related. Like, an integral is also called an antiderivative. So it's like the opposite of a derivative. It's pretty cool. Okay, so let's see. Another way to have done this, right, Jaden?
Yeah.
Would be to use trig. How would I use trig to solve this? How would I use trig to get this to get the hypotenuse? How would I do that?
Opposite over hypotenuse.
Okay, cool. So I would say sine, but watch that. Okay, so sine of 40 degrees is equal to the opposite over the hypotenuse. Well, these are two things I don't know, dude. What? Like, how does that work?
Don't go and do
You don't want to do that.
Just find out x and then find out.
Good. Yes, you could find out x and then you could do that. I'm going to show you an even cooler way to do it, right? So that you don't have to figure out x. Do you want to see it? I can definitely help with Calc 3. Yeah. So if I know this angle is 40 degrees and this angle is 90 degrees, how much is this angle?
180 minus 90 minus 40 is...
My man!
Good. 50 degrees, right? Yeah. The other way to know is like this must be 90 because this is 90, right? And triangles have to add up to 180. Yeah.
Yeah.
Good. Perfect. Okay. Cool.
Perfect.
All right. So now that I know this angle, now let's look at what the sides are, right? So this is the opposite, right? And then this right here is now the hypotenuse, right? Which we can say is like C, right? Okay, so try to use trig again. Let's try to use trig. See what we get. So opposite and hypotenuse. Good. Sine of 50 degrees is equals what?
Opposite is 15. Hypotenuse is C.
Good. I agree with that. All right. Michael Vernon says, "Can you help me with my relationship?" Which relationship? Which relationship do you need help with, dude? Your relationship with like math? Your relationship with this world? Okay, how do we solve for C here? This is a good question. Students get this wrong a lot. It's difficult sometimes.
Sine inverse of sine.
You don't want to do inverse. You do inverse sine when you don't have the angle, and you're trying to figure out the angle. And then 1 sec. Let me post this question. 1 sec. Okay. Thank you, Health Superior. I will do this one next. Okay. So you see it? How do we do this one?
So put sine 50c equal to 15. Move
Good.
It's number algebra.
Yes, yeah. So the reason why this confuses students a lot of times is C's on the bottom here, and they don't really know what to do, right? Cedric has it exactly right. You multiply both sides by C. The other way you can do that, you could pretend that this is over 1, and now you have 2 fractions, and this is where you can do cross multiplication, right? So I can do this times this, which is C times the sine of 50 degrees. Oh, fuck. Redo, sorry. No, nothing to redo. Chill out. Okay. And then that is equal to, Jaden, right? That's equal to 15.
Yeah.
Okay, now what do you do?
Divide.
Divide. I do integral stuff, for sure. I'm going to show everyone the website for how to submit screenshots so you guys can do it, because no one submitted anything yet, which is troubling. Because I've said many times how you do it. Okay, so C is equal to 15 over the sine of 50 degrees, yeah? Let's see what happens when we pull our calculator out. Let's see what we get. So 15 divided by the sine of 50 degrees, drum roll please, it's also 19.58. You see how you get the same answer?
Yes.
W live. Yes, cool. Very good job.
So Pythagoras also can, and then trig also can.
Yes, so in this case you used trig to figure out the missing hypotenuse. You could have also done trig to find x, and then done the Pythagorean theorem. That works as well.
But it's the
Both
longest way.
are valid. What's my thoughts on AI tutors? They're very useful. I use AI all the time, especially when people give me questions that I forgot how to do. I think the issue with an AI tutor is that most kids don't actually learn from it because they want a human to talk to. What's up, Zach? Thank you, Zach. And thank you, Fembox, too. Sorry, what would you say, Jaden? You gotta head out? Okay, good. All right, enjoy school, dude. Singapore, right? You're in Singapore? Malaysia? I forget where.
Malaysia, bro.
Malaysia, cool. All the way from Malaysia. Have a great day at school, Jaden. We'll see you, dude.
Bye.
Bye-bye. Nice. Yeah, for some reason my Twitch isn't showing up on my chat here. I'm gonna warn you, Zach. They just updated OBS to OBS 32. And it broke a lot of stuff today. So maybe test your stream out in the next day or two. Or just don't update. But yeah, shout out to Zach. 32A, yeah. If I said 21, all the kids would go wild.
That's dope.
Or 67. They love 67. What's up with the sound effects? I don't know. It makes shit fun. It's a stream, dude. What's up? I'm 14, but I took some Khan Academy trig stuff, but I don't remember much. Cool. Well, we did a little review here over trig. I have another question that Heath here submitted. This is a very good question. I will do this one. This is a physics question. I like this. If you also have a question, maybe you're going through something in school, it doesn't make sense, or your teacher didn't explain it, we have a website right here. You just go to www.actualdiscord.com/submit. It's the website down there. You, just put in a username you want to show up. You can choose and then take a screenshot of the question you want me to go over, and just hit upload. If you click this, it'll send it to me, to my Discord, and then I'll be able to pull it in on the live and help you out. So that's the best way for me to help you. You can paste your questions in the chat, but the chat gets so I don't know. It gets very full of things, right? So it's difficult to sometimes see all of it. Yeah. Any Gen A that can explain 6-7 to me, they just love the number 6-7. I don't know. I got 6-7 yesterday. Someone came up with... This is hilarious, actually. Someone on my stream asked a question. I'm trying to find out where it was. Oh, you know what? It was on page 67. It was hilarious. He asked me a complex multiplication question. And so I did it. And then the final answer was 67. And everyone lost their shit, but he used ChatGPT to come up with a question that the answer was 6-7. Complex analysis 2, you can try. I will try to explain that to you. But if I took complex analysis, I have not tutored it in probably a very long time. If you want help with complex analysis, so in my Twitch, there's another user named Zach, E2I. He's very good at complex analysis, and he has streams where he also does like math and science help. My background, I have a PhD in physics, plasma physics. I teach physics at UCLA, and I do this as part of a nonprofit to help other people. I feel smart watching this. Great. W. Okay, let me do a question. And then if you have other questions, please submit them to the website. You can also find the calendar and join the Discord if you guys want to be more part of it. Do I fuck with proofs? Yeah, proofs are cool. I did a proof yesterday. Someone gave me a logic question. I'll show it to you. It was low-key kind of tough. Which one was it? I think it was over here. Sorry. Was it this one? No. Where was that logic question we did yesterday? Oh, it was this one. Yeah. So I did this yesterday. This is like, I don't know, what do you call this? Like predicate logic or something? Nice. Okay, let me help out Superior because he submitted a question. Also, thank you, whoever. I see Logan. Logan put in one about gravitational laws. That's great. Cool. Nice. Okay, let's do this. A 5 kilogram box starts from rest and slides down a frictionless incline that's 8 meters long and makes a 30-degree angle with the horizontal. Calculate the speed of the box at the bottom of the incline. 2 ways to do this. You can use conservation of energy, or you can use kinematics. Both work. So, Superior, you want to tell me maybe what you're allowed to do? Are you allowed to use conservation of energy on this question? You can do algebra 2 if you want. That's cool. And then I see another fun one. Yeah, good job, you guys, figuring out how to submit screenshots. That's how you do it. Good. Excellent. Good job, everybody. Okay, I want to do conservation of energy because it's just so much easier. And it's starting from rest. This is 8 meters long. Cool. Like this length is 8. Speed at the bottom of the box. I'm going to do conservation of energy. All right. So because there's no non-conservative forces happening here, I know energy at the top has to equal energy at the bottom. Okay. And when we talk about energy, we can think about 2 main ones. We can talk about gravitational potential energy, which is called UG, which is equal to mgh. And we can talk about kinetic energy, which is the energy associated with something moving, which is 1/2 mv squared. Energy at the bottom is going to be the same thing. It's going to be the sum of these two as well. So what we look at is at the top, right? This thing will have gravitational potential energy because it is up some height. We're going to call this height equal to 0. So I need to know how far up this thing is. And so that's going to be equal to mg. And then this is where trig comes in, right? So if I want to know the height here, I have a angle. I have a hypotenuse. I'm looking for the opposite. I know that the sine of 30 degrees is going to equal to, let's just call this h over 8. And so this height h is then equal to 8 sine 30. So I can say 8 mg sine of 30 degrees. Kinetic energy, because this thing is starting at rest, that means the velocity is 0. So then this is going to be equal to 0. So this is our total energy at the top. So total is equal to 8 mg sine of 30 degrees. Let's look at our energy at the bottom. So once this box like falls all the way down, it's going to be at the ground. And so the height here will be 0. So this will be 0 at the ground. However, there will be kinetic energy because this thing is moving, right? The speed of the box at the bottom. And so now our total at the end is going to be equal to 1/2 mv squared. Stop yapping. If you listen to my yapping, you might get more intelligent. Or you can go swipe. You can swipe, dude, if you want to like go watch more feet pics or like thirst traps and like hot tubs. That's cool, dude. And I mean, it's all your choice, dude. Okay. Set these two equal to each other. M's cancel. You can divide by m. And then we can solve for v here. So I'm going to multiply both sides by 2. Multiply this by 2. So I get 16g sine of 30 degrees is equal to v squared. Sine of 30 degrees is 1/2. We should know that from the unit circle. W algorithm giving this live, looking for assistance. Yeah, fuck yeah, I got you, dude. Yeah, if you need help, again, there's a website. Submit a screenshot. I'll do it. 16 times g times 1/2, that's 8g. So 8g is equal to v squared. I'm going to assume g is just equal to 10. I know. Don't kill me. It's supposed to be 9.8. Whatever, fuck it. 80 equals v squared, so then v is equal to the square root of 80, which is the same thing as... what is that? 4 squared of 5. Cool. And there you go. That's your final velocity then. Nice. He too says, I got a 5 on AP Physics C because of you. Fuck yeah, dude. That's dope.
That's dope.
That's really cool, man. I'm glad. That 5 on AP Physics, dude, will help you out a ton in college because you get credit for it. Credit's great. We love credit. Why is it 4 surd 5? That's a good question. I can do it real quick for you if you want. So, and then I'll go through my chat. Just give me a second. So, if you have the square root of 80, Jaden, this is the same thing as 4 times 20. 20 is the same thing as 4 times 5. And then you want to pull out the pair of 4s, right? But then the 5 has to stay in the house. So this is why you get 4 root 5. Damn, this guy's respectful. I like that. Yeah, nice dubs, dude. Okay, let me go through my chat. Sorry. Blah, 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 blah. Thank you all the viewers, by the way. 133. That's fucking dope. This is the highest I've peaked at probably in the last month or two. I blame it on the algorithm now preferencing people who teach because school has started. All right, let's see. Michael Vernon says, what would you say is a characteristic about you that separates you from people that don't pass classes you took? Okay, cool. I'm not the smartest person. I don't ever claim to be the smartest person. I actually like barely passed my graduate physics exam when I was at UCLA. The one thing that separates me probably from people who fail is that I don't give up. And I think that is the most important thing, is to have perseverance. So, yeah, even if like you're struggling, I struggle through lots of stuff. And you'll even see on the stream here, somebody will ask me a question, I won't know how to fucking do it, and I'll struggle. But the struggle is part of the success. So I think the most important thing is to not give up. I mean, you should cut your losses at some point. You know, if you're like never passing, then maybe you should like choose something else to do. But the struggle, at least up to high school, keep pushing. Don't worry about struggling. How often do I stream? I stream 4 times a week now. I think I'm gonna move to 5, just because it's getting. That's my stream manager. Anyways, if you go to the website here, it's there. It's linked. It's in the description. You can click here on streaming schedule. And if you click on streaming schedule here, this is the live stream calendar, which will show the days that we stream. And then we have some other friends such as Zach, E2iPie. He does math education streams as well on Twitch. So he has one on Saturday. Am I American? Yes. I live in Los Angeles. Do I do biostats? I probably can. I can try. Yeah, sinusoidal equations are great too. Again, the best way, help me to help you, is to do what other students do here, which is send me a screenshot. If you send me a screenshot of a question, like this student did, I'll go over it, and I'll try to answer it for you. So, yeah. There we go. Ladder. Okay, that's another cool one. I like that. SPMO head. My opinions on 33 plus 34. Yes, I am alive. Yes, I am streaming on TikTok too. Yeah. It's just the chat sometimes doesn't like come through. OBS updated today. I'm super upset they did because they messed up all my fucking chat clients. I have like all my chats on everything, usually. Let me see if I can get it to work again. One sec. I can try to do grad level math, yeah. But yes, Nitzer, what is my opinion on 33 plus 34? It's pretty great. It's a pretty cool guy. Doesn't afraid of anything. Cool. This is another good one. I'll do this one. All right, let me see this. Considering that on Earth you are subject to the acceleration of gravity, where your mass in, I think probably in kilograms, and are the mass of the radius of the Earth respectively. If you weigh as much on the moon, calculate the mass of the moon using the radius of the moon and vice versa. Oh, okay. Yeah. I think they're thinking of this equation. So there's a big fancy equation for gravity. I have a Spider-Man voice. What the fuck's a Spider-Man voice? Okay. What question would piss me off? I do everything. I don't really get pissed off. What's up, Sebas? That's another good one. Okay. Cool. I see it. All right. So here, I'm going to do this real quick. If you weigh as much on the... Wait, I'm trying to read this. I'm having a stroke trying to read the English here. Sorry. If you weigh as much on the moon, calculate the mass of the moon using the radius of the moon. Wait, what? Okay. Okay. If you weigh as much on the moon, calculate the mass of the moon using the radius of the moon? Yeah, but I would need to know also... Yeah, I think there's something missing here. Let me see. Yeah, okay. Well, anyways, here, if you can submit this, I need a little bit more information to do this one, but this is the equation you use in order to figure out what the force of gravity is of you. And then you can always convert that force into what is like an apparent weight by doing Fn over g. None of the constants copied over in that question. Yeah, it's missing some stuff. I agree, Femvox. Yeah, it's annoying. Mad mommy vibes from you, bro. Respect for teaching math. Def gonna be in your streams. Thank you, dude. I don't know what the mommy vibes are. Please, like, what the fuck's mommy vibes? Okay, let me do this one. This is a good one. A ladder is on a ladder is 5 meters on a horizontal ground resting against a vertical wall. The ladder makes a 42 angle degree with the ground. How far up does the ladder reach? This is a great trick question. Okay, cool. I like this. Okay, so we know the ladder. I'm gonna make the ladder brown here. I'm gonna say the ladder here is 5 meters. Ooh, sorry. Let me see. 5 meters long. An 82 degree angle with the... Okay, so that's actually a really steep angle. Let's make that like really steep. One sec. Let me make this steep. Kind of like this. 89 degrees? Or 82 degrees? That's really, really steep. What? Why is astrophysics harder than any other physics? Probably because we can't actually measure that shit, like, in person. We gotta, like, send things and, like, guess. This is pretty easy physics because we actually get to measure this. How far up? Okay, cool. This is another trig question. Not too hard. This right here is a right triangle. Right? And this is the hypotenuse. This is the opposite side to the angle. So opposite hypotenuse is sine. Sine 82 degrees is equal to opposite over 5. So then you can just solve for this, which is just 5 sine 82 degrees. Which, let's pull it up real quick. I'm going to reset my chat as well, because I'm annoyed that I can't see the TikTok and stuff as well. 5 sine 82 degrees. You get 4.95.
That's
nice.
dope.
Can you do a related rates problem with the ladder? I know what you're talking about. Yeah, the typical question with the falling ladder is it's if the ladder is falling at this rate, like how fast is this moving? I love related rates. Yeah. So again, go find me a screenshot. Help me help you, because it takes me time to go find questions. If you go find me a question, I'll just do it. This looks like Spanish, but it is calculus. What a distinguished ladder, indeed. And one sec, let me reset my chat client. I think what is this thing called? I think Social Stream Ninja is just like choking. Let me kill it real quick. See if we can get it to start. Social Stream Ninja, come on, girl. Come on, girl. I know you can work. Where is my chat? Where's my chat? Okay, there we go. There we go. Okay, cool. All right, let me activate this source. Let me select this source. Cool. And then let me select TikTok. Cool. All right, we should all be up again. Good, we are. Okay, let me see if this works. Okay, nice. That works. Let me see if TikTok works. Sorry, I just want my chat to work across all my clients. I get annoyed when it doesn't. Alright, TikTok's not working. Alright, whatever. Fuck it. But I think YouTube's still working. Let me make sure YouTube's still working. Come on. Yes, that's still working. Great. Okay. Nicholas says it's about transferring that into a defined integral function over defined integral. Sorry, I guess I could. No, that's okay. I get it. You want to turn this limit into a defined integral. So, what I see this as is this is a sum, right? So this is the sum from n equals I want to say 1 to infinity of no n. Wait. I'm seeing like an n here and an n here, so like it's a limit and a let's forget the limit for now. Let me just do the sum. This is the sum from, let's say a is equal to 1 to infinity of 1 over the square root of n squared plus an. I think, right? And actually this goes up to n. Right, oh, but this is also going to infinity. Okay, wow, this is very interesting, actually. N seems to be constant, but the coefficient is changing. Yeah. So, I mean, that's why I said it was equal to an here, right? Because in this case, right, a is equal to 1, a is equal to 2, a is equal to 3. You see how we have the 1, 2, 3, and then eventually a is equal to n. Okay. Very cool. And then we want to try to write that as an integral. Okay. Femvox says x squared y plus 3xy minus c to Callista and YouTube. Okay. Callista, if you're asking questions, Femvox just answered something for you. If you guys want to view this better on like a horizontal, you can watch it on Twitch too. If you're cool with the shorts and the vertical, totally cool. Stay here. It's great. I stream on YouTube Shorts because it's a great way to like get exposure and reach people. Okay. Let's try to, here's what I'm going to do. I'm going to try to factor out an n out of this, okay? Because I see square root of n squared and then over n. So let me factor out a 1 over n over this, right? So I think this is going to be the sum a equals 1 to infinity. If I pull a 1 out of n out of this, right? This is the same thing as 1 over n square root of 1 plus a over n, right? Do we agree with this so far? Yeah, the limit could be the sum as it approaches n. Yeah, for sure. Okay. I think I see like I see some type of sum here. A equals 1 to infinity. But then it's also as like n, and then we're also taking the limit as n goes to infinity. Oh, very cool. Whoa. This is very cool. Okay, so if you're taking the limit as n goes to infinity of sigma a equals 1 to infinity, 1 over n, 1 over the square root of 1 plus a over n, this is a Riemann sum. Yeah, no, yes, you could pull the n out. Yeah, you could pull this out because it no longer depends on it. You totally cool, Abdullah. But let's look up like what a Riemann sum. This looks exactly like a Riemann sum to me. Exactly. 1 over n would be delta x. Yeah, exactly. Fuck, where's that? It's this. Yeah. This is what I want, sorry. This is really cool, actually. It's like hidden, is what it is. So, you learn, right, that integrals can also be written as infinite sums, right, of some function where delta x here is equal to b minus a over n. So, yeah, exactly, Nicholas. So, in this case, this is like 1 minus 0 over n. So, that tells me right away that this is the integral from 0 to 1, right? So, delta x in this case, to be 1 over n means b minus a. Delta x or delta rune, yeah. Okay, so watch what this is, right? And then, okay, so then I just have to define what f of x is. So I'm going to say that this whole thing here, right, f of x is equal to 1 over the square root of 1 plus x. Okay? Where x is equal to a over n. The reason why I'm doing this because I know this is an easy integral, and it saves me the hassle of having to u sub it again. Okay, so now look what we have. Limit n goes to infinity, 1 to infinity, 1 to n, which is to infinity. Great, awesome. 1 over n is now b minus a, and now this is f of x. So this is the same thing as the integral from a to b, which we said was 0 to 1, of f of x. So that's f of a over n. Well, okay, let's just say f of x dx. Okay, where f of x, okay, where x is equal to a over n. So, fuck. I gotta remember, like, how this works with the derivative. Actually, no. No, I don't think I need the... Oh. Yeah, this is very cool. Okay. Yeah, sorry. No, this is just f of x, right? Where I'm saying x is equal to a over n. And... Okay. So I think this is zero. This is the integral from 0 to 1. What's an integral? It's adding up the area underneath a curve. So if you have a function that looks like this, finding the area is the integral from a to b. We would say like f of x dx. It's like adding up a bunch of these. Do the integral of the square root of tan x. Yeah. Okay, cool. Okay, so this ends up being the integral from 0 to 1 of 1 plus x dx, right? Which, this is a simple integral, right? This is the same thing as u is equal to 1 plus x. So du is equal to dx. So this is the same thing as the integral from 0 to 1 of u to the minus 1 du. Integrating that, raise the power. Oh, so is this like ln then? You're such a W for this. Yeah, okay, yeah, sorry, Nick. Yeah, let me roll this back. I'm close. Sorry. Okay, how did I catch the limits to be 0 to 1? Okay, good. Let's roll all this like way back. Because I'm getting a little bit confused in how the limits are being applied. Okay, so watch. We agree to this point, right? We agree that if I rewrite this thing, we agree that I can write this infinite series like this, okay? Because I see I'm doing like 1n, 2n, 3n, 4n, so that's really an. Can't agree, if not understand. I'm sorry. Then what I do is I pull out a 1 over n from it, and then I get to here. And then we do this a lot in math. It's called by inspection. So I'm inspecting this compared to this. And I want to see if they look similar. Thank you. A goes from 1 to n, not 1 to infinity. Yeah, exactly. Yeah. My bad. Yeah. So, in this case, Yeah, this needs to be not to infinity. This needs to be to n. Which, this part now looks exactly like this. Right, yeah. Sorry, let me fix this. Without the limit here, I would have to say to infinity, but I can also say n here, and then say the limit as n approaches infinity. Ohm's law is better. I mean, I do like Ohm's law. Okay. So let's inspect part by part to make sense out of this. So I have this, right, where I can also write this as the limit as n approaches infinity of, instead of delta x, I'm going to say b minus a over n times f of x. And then, sorry, there's a summation here. And then I'm going to say I equals 1 to n. Okay. fxi. Where xi is equal to my initial point plus I times delta x, right? And that's how a Riemann sum works. So this thing right here, or this like whole part right here, looks exactly like this. Let me use different color, sorry. Let me use gold. I like gold. This looks like this, right? Do we agree with that? So in order to get 1 over n, that means my b minus a has to be equal to 1. And the easiest way to get b minus a is equal to 1 is for this to be equal to 0 and this to be equal to 1. So you have 1 minus 0. So that tells me right away that this must have been 1 minus 0. So now my integral is going to go from 0 to 1, right? Now here's the tricky thing. It's this function here. And then this is dx. Cool. So the function... Yeah, you see it now? Cool. All right, the function is this, right? This part is the function. Which... okay. I'm going to define this as f of x is equal to 1 over the square root of 1 plus x. Okay. So then I'm doing the integral of this, but we're doing it at x is equal to a over n. So this is f of a over n. But then this is the limit as a approaches n, right? Isn't that just f of 1? This is the part, Fembox, I'm a little confused at. Because I need it to be dx. So, sorry, I think I just do this. I think I just say f of x. Which is... yeah, x sub I is equal to a over n, but not x. Can't you just use the f of x you have written? Like this one, right? Yeah, I think I can. So 0 to 1. Like, plug in bounds, right? I think we're looking too deep into it. Yeah, maybe. We're going too far. Okay. So... cool. Yeah, I think we can just do this. I think this is it, right? And this is an easy integral to do. Because u is equal to 1 plus x. So du is equal to dx. And so now I have the integral from 0 to 1 of u to the minus 1/2 du. Integral of this is you raise this power by 1, so negative 1/2 goes up to positive 1/2, and then you divide by the new power. So dividing by 1/2 is multiplying by 2. So now you have 2 u to the 1/2, and then that's evaluated from 0 to 1. But I need to resub in what my u was. My u is 1 plus x before I do that. So then it's 1 plus x to the 1/2 from 0 to 1. Exactly. Thank you, Shmuley Cohen. So when I plug this in, I think I get 2 times the square root of 2 minus 2 times the square root of 1, which is 1. Okay. So I think this is it. I think this is the final answer. I'm pretty sure. Delta Rune mentioned. What's up, Evoli? This channel's absolutely gold. I'm a high school student who really loves math. Nice. Yeah, awesome, dude. Yes, right. All right, good job. We got it. Yes, good. Good job. Good question.
Well done! Well done!
Nice. Yeah, no, for sure, dude. Okay. Next screenshot that got submitted was this one. Again, if you got a math or science question, you want me to go through it, send me a screenshot. I'll go through it. Evoli, you let me know when you want me to go over your... We were doing, what was it? Linear regression by hand? Where was it? Oh my god, this is so much pain. Where did we do it? Was it here? That was curvature. That was the proof. Alright, I'll just let you know. Cool. Alright. I'm trying to remember, like, where I did that question, though. It's like, where was it? It was right after Nick, wasn't it? I feel like we did it. Did I work with you yesterday? This was trig functions. That was 67. Yeah, whatever. People making me saying 67, 69. No, maybe it was a couple days ago. Sorry. Yes. I remember which one it was. It was... No. No, that was that. Oh, I for sure put this somewhere, dude. Yeah, the frustrum of a cone. I'm gonna work on that one, too. I'm gonna be so upset, Evoli, if somehow I didn't save our work from that one. Oh, here it was. This was it. This was it. This was it. This was it. Okay. Yeah, I'll do this at some point later tonight. But this was... figuring out the correlation linear regression for data points using manual by hand methods. You saved it as well? Great.
My man.
Love that. Yeah, go to page 67, he says. Go to page 67 is literally somebody trolling me about a question that the answer was 67. It was too funny. Okay, let me go to this question. All right. Find the slope of the tangent line to the graph of the function at the given point. Cool. Tangent line. So, the slope of the tangent line is the value of the derivative at that x coordinate. So here, I know that sounds a little bit complicated. So, for those that haven't taken calculus yet, all right. So we have g of x, which is a simple function, but it's okay. 9/4 x plus 2. So what? That probably looks something like this. Well, let's pretend it wasn't something so simple. Let's pretend it was something like this, okay? The slope of the tangent line, let's say like right here at like x is equal to a. This is called the tangent line. And then the slope, and let's say this thing is equal to g of x. Let's say the function is g of x. The slope, in this case, would be equal to g prime of x, but then you evaluate x at a. So this would be g prime of a. That's the way to do it. Okay, cool. Yeah, I'll ping you. I'll ping you, Evoli. Yeah. So, looking at this function, to find the slope of the tangent line, we need to figure out what the derivative of this is first. Okay, first step. Exactly. Well, the slope is not 0, so watch. So, g prime of x is just equal to 9/4, right? Because the derivative of x to the first is just x. And the derivative of 2 is just 0. So it's just 9/4. The cool thing is that the derivative does not depend on x. And that should make sense. Because the graph 9/4 x plus 2 looks like this. It's just a straight line. Where the slope is constant everywhere. Okay, the slope is always this. Okay. So, that's the slope. Oh, and that's all we have to do. Oh, cool, done. Slope's 9/4. Yay. I like that question. That was a very nice question. Yeah, because bro, it's already done. Yeah, awesome. Nice. Okay. Fridge has submitted a question. What's up, Fridge? Thank you, Fridge. Are you hiding the snacks, Fridge? Fridge is always hide the snacks, dude. Okay. I'm probably going to regret this one. Integral of cosine to the 4th 3 alpha. Ew. Fuck, what? Do I need a triple angle identity here? Is that what we need? That's going to hurt my soul. You know that, right? Someone was asking me... what did you guys ask me? What's a question I could give you that you would hate? Probably something like this. It's okay, Fridge. I don't hate you for it. This will just be fun. Okay, let me look up some triple angle identities. I think I need some triple angle identities. Or I could do power reduction. Okay. Yeah, here we go. I'm cool with this. I'm going to trust that this one's right. Please be right, Clark University. The cosine to the 4th needs to be dealt with. Oh, you're right. The u equals 3 alpha immediately deals with the 3. Correct. Oh, I see. Yeah, maybe I want to do the power reduction first. Right, Fem? Because, this is true, right? The issue is that once I replace this part with this, then I need to do that to the 4th power. And that's going to suck. No. You don't want to do that. That's really bad. Yeah, that's going to hurt. Because, bro, like, do what? Then this is going to become, like, sine to the 12th.
You done messed up, AA Ron!
Yeah, your teacher says you need to expand. Well, okay. I don't know about expand. I think you need to do a power reduction is what you need to do. So, there are these things called power reduction formulas. And they're here. Let me copy the image. Okay. They said, well, you can't really expand anything here, is the issue. Yeah. Yeah. I think this is what they mean by... well, okay. Here's how you could expand this. You can write this as cosine squared of... I'm going to say everything's dx instead of d alpha just because alpha sucks to write. Yeah. Cosine squared 3x times... Yeah, there are no identities for cosine to the 4th. Correct. Cosine squared 3x. Right. Exactly. So, from here, you can use this one. Okay? Which means, now you're going to have the integral... So, instead of cosine squared of 3x... So, this x here is now a 3x, which means this is now a 2 times 3x. So... Hang in with me. Tell me if anything, if any of this doesn't make sense to you because I'm going too fast. Please let me know, and I'll slow it down a little bit. But I believe this is 1 plus cosine of 6x all over 2 times 1 plus cosine of 6x all over 2. What's good, Dr. Mauger? You just finished your night class? Nice, dude. Nice. Dubs, dude.
That's dope.
Dubs. Yes, exactly, Abdullah. You could replace the cosine squared with 1 minus sine squared, but it doesn't really do anything. Yeah, because then I'm just going to use this one. Okay, good so far? Are we chilling? I think we're chilling, yeah? Okay, cool. So I can pull out a 1/4 from this, right? So 1/4, and then this is the integral. Well, now we have to FOIL this. I guess that's expanding, maybe, right? So that's going to be 1 plus cosine squared 6x plus 2 cosine of 6x. Right? We agree with that so far? Okay. Okay, so now I think I can use this. I think I can use this. Well, wait a minute. 2 of these integrals are trivial. This is an easy integral to do. This is an easy integral to do. This one kind of sucks, right? I think I just want to reduce this one again. I actually don't think I want to do any of this yet. I don't think I need any of that. Yeah. For the love of God, don't use that triple angular. Thank you, YouTuber. Yes, I'm just gonna use this again. Sorry, I was getting distracted by the shiny things. I was like, bro, let's do it. No. Don't do it. Don't do it. Okay. We're going to use this one on this bitch again. Okay, cool. All right, so now it's 1/4 integral 1 plus, and then this is another 1/2 plus 1/2 cosine of 12x, right? Plus 2 cosine of 6x. Okay, cool. Power reduction. I'm tired, boss. I'm tired too, man, dude. Okay, this is okay. These are easy integrals now to do. Okay, so this is 1/4, the integral of 3/2. All this times, right? Plus the integral. Okay, and don't get mad at me for not putting dx. Plus 1/2 cosine of 12x dx plus integral of 2 cosine 6x dx. Please add, yeah, please clap. Just need like Jeb Bush here just being like, please add dx. Good, where do those 2 1/2s come from? Okay, very good, Fridge. Okay, the 2 1/2s came from this. See how it's 1/2 plus this over 2. So rather than like, I was cool pulling the 1/2 out of both of these things here because these would multiply and then I could just pull it out as a 1/4 times everything. I haven't forgot the plus c yet, but yeah, that is annoying when that happens. So this is 1/2 and I'm saying plus 1/2 of this, right? And that's converting all of this into these two things. Yeah. And then I'm combining that into 3/2. Yeah. Oh, yeah. Makes sense. Yeah. We love it. We love it when shit makes sense. Okay. Let's see. So that's 1/4. Integral of 3/2 is just. Is there any bounds on this shit? No. No bounds. Okay. Great. 1/4 plus 3/2 x plus integral of this. So I always say this is kind of like a reverse chain rule. So if it's the cosine of 12x, I know I need to divide by 12. So that's going to be 1/24 sine of 12x is what this goes into this. Really, you need to do a u sub, but this is one of these tricks in calculus. You should get good at doing what I call like the reverse chain rule for integrals, which is kind of doing u sub in your head. You know, if like something is multiplying by it, you're just going to divide by it. So I'm dividing by 12 to get 1/24. And then the integral of cosine is just sine. And so in this case, I'm dividing by 6. So this is going to be 1/3 sine of 6x. And then this is all plus c. And yes, sorry, the 1/4 is a factor on everything. Thank you. Thank you, Femvox. Sorry. Yeah, I forgot this. All right, don't murder me. Okay, so wait, 1 sec. Sorry. 3/8 x plus 1/96 sine of 12x plus 1/12 sine of 6x plus c, and you're done. Okay, that's a cool question. Thank you, Fridge. It was a great one. That was so helpful. Sick, dude. Nice. Yeah, if you ever want to get like more help, please come on by. I'm planning on stream. I used to stream only 3 times a week, but with the school year starting, I'm bumping it up to 5. So come on by. Happy to help. We also have a Discord you can join if you want to get help when I'm not streaming, because I can always point you to other people that are streaming and doing help. But yeah, good questions. I'm the GOAT. Thanks, dude. Okay, let's see. What's the next question from someone? Oh, nice. Thank you. Someone gave me the constants. They gave me the constants. Nice question, Fridge. Nice on. Sick. Okay, look. Okay, now this works. Okay, good. Beautiful. Okay. Right. So, yeah, this was the big scary equation that I had from here, right? This homework right now is giving me AIDS. I'm sorry, dude. They do have medication for that these days, though, so you don't have to die. Let's see. Okay. Considering that on Earth you are subject to the acceleration of gravity is equals to that. Yes, this is AP Physics 1 probably. It's close. Blah, 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 blah. If you weigh 1/6 as much on the moon, calculate the mass of the moon using the radius of the moon and vice versa. Check your calculated values against the knowns. How close are they to each other? Is it a good estimate to say you weigh 1/6 as much as the moon? Okay, cool. I like that. So, G is equal to... Wait, what is this? Is the local... Okay, I see what they're saying. Considering that on Earth you're subject to acceleration of that, blah, 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 Fg equals mg, and G is equal to... Right, okay. I think this is like extra information. I don't feel like we need this. Or maybe we do? Okay, so weigh is kind of a misnomer, right? Because your mass does not change. Weight is the force of gravity that you feel, which is really the normal force of the ground pushing back up on you. So, for instance, if you're a person chilling like this, you feel what's called a normal force that keeps you from falling down through the ground. And that normal force you feel is your weight, per se. This is why, for instance, if you have additional forces like pulling you up, now the normal force goes down. Because you don't need as much normal force to keep you up. And this is what, like, buoyancy is. For instance, in water. It's pretty cool. So, the force of gravity on the Earth is equal to mg, right? And that's also equal to how much you weigh. But we're saying that the amount you weigh on the moon is 1/6 that, okay? So your force of gravity on the moon needs to be 1/6 the force of gravity you feel on Earth. So what I'm going to say is that mg divided by 6, right? So this is force of gravity on Earth needs to equal this big G m1 m2 over r squared, where in this case this is going to be of the moon, or actually let's change it. Let's say this is the mass of the moon, and then this is u, okay, and then this is also u. Yeah. Well, see, here's the cool thing, right? Okay, so let's agree here. Let's agree here right now, right? The force of gravity on Earth that you feel is equal to your mass times little g, which is 9.81 approximately, divided, and then we're going to say that that weight is 1/6. Wait, no, sorry. This is the 1/6. Wait, no. Okay, sorry. This is how much you weigh on Earth, but then divided by 6 is now how much you weigh on Earth, on the moon. Okay, does that make sense? It's kind of a backwards thing here, right? How much you weigh on the moon is 1/6 how much you weigh on Earth. Let me draw my arrows here a little better. Good, thank you. Force of gravity on Earth Good. And then the force on the moon is mg over 6. Great. Cool. Okay. Excellent. Good so far. Here's a cool thing. So when you use this, the Newton's universal law of gravitation, this is for any two objects, mass 1 and mass 2. In this case, mass 1 is going to be us, and then mass 2 is going to be the mass of the moon. And then r is going to be the distance from the center of the moon to the surface of the moon. Yeah, force of the moon is W6. That works as well. Okay, so these are both U, which means now I can cancel these out. Okay, so these go away. And so now I'm given, so this is little g, so 9.81 over 6 is equal to big G. And then, what are we trying to determine? Sorry, calculate the mass of the moon. Okay, so we're trying to figure out M2. Given the radius of the Earth. Or wait, what? No, I need the radius of the moon. Using the moon's radius. Okay, cool. Where's the moon's radius? Where did they put it? Oh, here we go. Sorry. Moon radius is this 1737.5 times 10 to the 3. So 1737.5 times 10 to the 3, and then that's squared. Algebra skills are being tested here. I agree. Okay. You know what? Yeah, I'm going to leave everything. No. I was like, I should put everything back to variables, shouldn't I? The problem is I have too many m's and g's like floating around. Okay. So the mass 2, which is equal to the mass of the moon, is equal to 9.81 over 6 times 1737.5 times 10 to the 3. Oh, thanks for the follow, dude. Times 10 to the 3 squared. And then that's divided by G when we move that over. And that's the 6.67 times 10 to the minus 11. Right? Well, here, let's just see. Let's just see what happens when we do this, right? (9.81) divided by 6 times 1737.5 e to the 3 squared divided by 6.67 e to the negative 11. 7.4 times 10 to the 2. 10 to the 22. Yeah, organic chemistry tutor is pretty good. Okay, so mass of the moon. Yes, I could put that up as 10 to the... Yes, I could. So that's 7.4 times 10 to the 22 kilograms. And let's go check. Yeah, quantum cavity is great too. Yeah. I think this is... This is close. Let's see. How many zeros are there here, dude? This is an absurd amount of zeros. So 3, 6, 9, 12, 15, 18, 21, 22. Yep. So their answer is 7.35 times 10 to the 22. And we ended up getting 7.4 times 10 to the 22. I'd say it's pretty close. Nice. That's actually really close, yeah? Does that make sense?
Well done.
I think when they said the vice versa thing, yeah, it's a pretty good estimate. It is just algebra skills. If you want to do vice versa, then what you would do is you would be given the mass of the moon and you would solve for the radius. So you would be given this, and then you're solving for this. And you should get a value that's pretty close to this as well. Yeah. Yeah, you're very welcome, dude. Nice. Okay, cool. Algebra is important. Algebra is important. I have like some videos on like really basic algebra. Trying to think where on my YouTube channel I have that. So we go to here. Algebra. I think I have videos on it. Yeah, here we go. The best way to solve for x using basic algebra.
Here's how to solve for x with basic algebra. So here we have...
Yeah, so here's like kind of my tricks for like how to solve for x if you want to like watch a 58-second short with memes and fun sounds in it. GG's, or should I say GGG's. Algebra is your clingy ex that will never leave you in peace. No, bro, that's trig. Algebra I like. Sine and cosine I was so scared of for the longest time. All right, let's see. All right, this is a great question. This is a related rates question. Trig is the abusive relationship. Yeah, she beats me because she loves me. Okay. A ladder 10 meters long is leaning against a vertical wall with its other end at the ground. The top end is sliding down the wall. When the top end is 6 meters from the ground, it is sliding down at 2 meters per second. How fast is the bottom moving away from the wall at this instant? This is cool. Yeah. This is related rates. I'm going to show my tricks for related rates. Very useful. Okay. So, this is 10 meters long. The top end is sliding down the wall when the top end is 6 meters from the ground. Okay, cool. So we know this is this. This is 6, right? This is really cool, actually. Do you know how I know exactly how much this is? I know this is 8 right off the bat. Does anyone want to tell me why I know this is exactly 8 without having to do, like, anything in my head? Or any serious things? Three, 4, 5.
That's gay.
Exactly. Yeah, so Pythagorean triples, these are very important. So these things satisfy a squared plus b squared equals c squared, but also the multiples of them do as well. So 6, 8, 10. There you go. Yes. Yeah, for those watching, okay. Whenever teachers design questions, they design them because they want easy numbers that are nice to grade. You should always be on the look for Pythagorean triples. They pop up all the time. Yeah, 3, 4, 5. You get it, Badilla. Okay, cool. All right, so I just know this. All right. Excellent. Let's define like a coordinate system. I kind of need that, right? I'm going to call this x is equal to 0. I'm going to call this x equals positive 8. I'm sorry. Positive x is moving to the left. I'm sorry. It is. Don't hate me. This is y equals 0, and then this is going to be y equals 6. Okay, cool. So, I like to see what rate I'm given and what rate I'm trying to determine. The rate I'm trying to determine is how fast the bottom is moving from the wall, right? So that's how fast this end is moving in this direction, okay? That's going to be dx dt, right? Note that, like, x is being measured from here in the positive direction, so dx dt is going to be equal to what we're looking for. Thank you. What's up, Recky Rec? Good to see you. Okay. So dx dt is equal to 8. Sorry, that's what we're looking for. And we know it's sliding down at 2 meters per second. Okay. So this part tells me that this end is falling down at 2 meters per second. So in that case, that's movement in the y direction. So I'm going to say dy dt is equal to -2. Okay, because it's coming down. Awesome. Is it a Pythagorean triangle? What is a Pythagorean triangle? What the fuck does Pythagorean mean? Okay, anyways. So now that you have your two rate variables, x and y, you need an equation that relates x and y. Okay? What I notice here, right, is that because this ladder is not changing in length, right, as this thing, like, falls down... can I grab it? No, I need to grab the right one. As this keeps falling down, okay, the length of this ladder is going to remain the same. That's the hypotenuse. And it will be a right triangle that this ladder makes, because you still have this and this making a 90-degree angle. So what I can say here is that whatever the horizontal position of the ladder is, which is x, that squared plus the vertical position of the triangle, y squared, is equal to 100. Yeah. Pythagorical is a feminine adjective meaning Pythagorean. Oh, I didn't know. That's cool. All right, cool. So this is my equation. These are my rates. The next thing to do is to take, you have to take the implicit derivative of all this stuff, all right? So I'm going to write it this way. People are going to get really upset with me that I do this, but just hang on. To implicitly derive this, right, I'm going to get that 2x dx plus 2y dy is all equal to 0, okay? My method for doing okay, yeah, I know. No, implicit derivatives. Implicit derivatives are really easy. All you got to do is treat every variable as something you take a derivative to, and whenever you attack that variable, you write either dx or dy depending on what derivative you did. In this case, I took a derivative with x when x squared became 2x, so I'm going to write dx. It's the same, right? So instead of y squared, I'm going to write 2y, but because I took a derivative of y, it's now dy. I have a whole video on this. If you are scared about implicit differentiation, it's one of my most popular videos on YouTube. Also because people just get so upset at it. Because of... I just divide everything by dx and dy at the end. Here you go. Look, this one has 132,000 videos on it. This is back when I wore glasses 4 years ago. But yeah, here. Go watch this video, please. If you're having troubles with implicit differentiation, I would love to help you. There it is. Okay. All right. The next step I'm going to do is I need things to be like dx dt, dy dt, okay? So I'm going to take this and divide by dt. I'm going to take this and divide by dt. And so now what I'm given, right, is that 2x dx dt is equal to negative 2y dy dt. Uh-oh, 3 hours to complete 6 questions. Can we know the AdSense you made from that? 0. I made absolutely $0 from that video because I wasn't monetized when I created it. Blessed YouTube, right? Yeah, they got all my views, but I made exactly $0 from that video. But you guys watching helps me get monetized, so I appreciate that. It was for the love of the game. It really was, honestly. The forbidden divide by dt, right? Math people, like this one little trick, math people hate. They hate when I do this. They hate when I just divide both sides by dt. Whatever. It works in intro calculus. Just let it happen. Cool. So yeah, now you can solve, right? So dy dt is equal to minus 2. Okay. So we have 2x dx dt when I'm trying to look at this rate. And what I know is that the x position of the ladder is 8 when we're asking how far is it moving, and the y position is 6. Okay? So that's 2 times 8 dx dt is equal to negative 2 times 6 times 2. Cancel the 2's. And then you get that dx dt. Oh, sorry, this was a minus 2, right? So that should be positive. This is positive. Is equal to 12. 12 over 8. So yes, good. Is equal to wait. I think it's 3/2. What'd you get? Did you get you got 8/3? Wait, sorry. Divide by 4. I think we get 3/2. Unless I'm tripping here. I think it's 3/2 meters per second. Which to me makes sense. I feel like this should be falling faster than this. Yeah. Makes sense for it to be 3/2, right? Yeah. Answer key says 3/2. Nice. Sick. Love it.
Well done! Well done!
Fembox says he got 3/2 too. Fembox is my word of truth. Wow, we got a lot of good questions coming up. All right, let's see this one. Ooh, this is cool. This is very close to a question I taught at my UCLA class this summer. Yeah, this is very similar. This is very similar to anyone from UCLA. This is a 1B class question for sure. What's up, Darren? Okay, the pattern of wave displacement nodes and antinodes of a standing wave is AN, AN, AN. Okay. When the frequency of the wave... So this is cool. So this is closed open, right? So when one end of your pipe is different than the other end, that's called an open-closed pipe. So let me show differences. Gotta go. I gotta start my statics. Good luck with statics, dude. Drop a like, follow, so turn notifications on if you want to see next time we're streaming. Happy to help you guys out. Nah, 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 nah. Hey, hey. Yeah, okay. Standing waves. Yeah. So you can have, like, open and closed. Yeah. Statics. Femvox likes statics.
Nice.
Right. Okay, cool. I want one that has all of them in it. This has all of them in it. Yeah. Cool. This looks decent. I don't know what to put here. Is this AP Physics? I don't know what this is. This was submitted by Odin, I think, who is in AP Physics. Solve mine, please. I'll get to it. There is I see a list of them. Keep putting in questions. I will do them. We're on this one right now. This one right here. And then I'm going to do Nocturnes 1. And then this one. And then this one. And then this one. Cool. Signal processing. Yeah. Okay, let me turn this off. Right. So if something is closed, this is the wave pattern you get. Where this is a node, this is a node. If something is open, you get antinode. Antinode means like it's up in the air. It's not hitting the whatever the axis of symmetry. If something is open-closed, this is a node, and this is an antinode, which is what we have here, right? I have a node and an antinode. Okay, cool. And let's see, how many nodes do we have? We have 1, 2, 3. Okay, so let's look here for where we have 3 nodes. So 1, 2, 3. This is our pattern. This is what we're looking at. Okay. Cool. And then, do we know the length of the pipe? Oh no, we gotta find the length of the pipe. This is physics, yeah. And it says the frequency is 975. Okay, this is cool. Okay. So F is equal to 975. Okay. But for this type of wave, the frequency is 5 times the fundamental. So F naught is going to equal to 975 all over 5. Which is, what is that? 175? Is that 175? No. 195. I think. Yeah? Am I right? I don't know. Yeah, good. 195. Nice. Thanks, Fem. Cool. Right, so the fundamental frequency is 195 hertz. Cool. Find the length of the pipe. Okay. So, the speed of sound is 344 meters per second. Here's the condition. So, V is equal to F lambda. So velocity is equal to frequency times wavelength. In this case, the velocity is 344 meters per second. It's usually 343 for sound, but whatever. The frequency we figured out was equal to 975 hertz, because that's not the fundamental. That's the harmonic, the overtone. And then we got to figure out lambda. So lambda is equal to 344 over 975. And that's going to give me 0.35 meters. Yeah, cool. All right. Good. Good so far. And then find the length of the pipe. Okay, cool. So if the pattern looks like this is cool. I want to think, how many wavelengths do I have, right? So I have at least one wavelength here, right? Or sorry, I have yeah. Right, is that one wavelength? Yeah. So one wavelength is this, and then this right here is a quarter of a wavelength, right? Like if we go just from here to here, that's a quarter, that's a half, that's 3/4, that's a whole. So we have 5/4 of a wavelength is equal to the length of the pipe. So 5/4 lambda is equal to the length of the pipe. Lambda was this. So you just do this times 1.25. Exactly, Abdullah. Yeah, and that equals 0.44. So that's 0.44 meters. Nice. I think that's good. Find the next standing wave frequency. Okay, this is the cool thing. For things that are like closed open, the fundamental frequencies, it goes 1 f0, 3 f0, this one's 5 f0, and the other one is 7 f0. So the next fundamental would be equal to 7 times 195. Which, what's that going to be equal to? 1365 hertz. Nice. And you're done. Good job. Yeah, Abdullah says, would the one beyond that be 9? Yeah, exactly. Yep, you're right, Michael. Yep. So 13579. It just keeps going on. In the case where things are either closed or open, it goes 1, 2, 3, 4, 5, 6. It doesn't skip the odd ones, and that has to do with the boundary conditions of like sine and cosine. Brody has a question with. Oh, that's cool. Yeah, let me add that to my screenshots. Oh, sorry, I gotta. Let me screenshot that in for you, Brody, real quick. I'll add that to the list of things. All right, let's see. Next one is from Nocturne. This isn't too bad, Nocturne. I think this is kind of a fun one. All right, Nocturne. Evaluate this integral. So this is where the power rule comes in handy, right? This is just a nice simple polynomial. So the rule when integrating is you take whatever this is, you raise the power by 1, divide by the new power. So 5 goes up to 6, and then we divide by 6. So that's going to be 2 over 6, x to the 6th. This is going to be minus 3 goes up to 4, divide by 4. So that's going to be minus 8 over 4, x to the 4th. This is going to go up to 3. So plus x to the 3rd over 3. This becomes x squared over 2. And this becomes 2x. Well, here's a tricky thing. This is the same thing as x to the 0. Let's remember, anything besides 0 to the 0 power is just 1. They're so refreshing compared to the cosine to the 4th, Abdullah. Yeah, right? Yeah. So this is x to the 0, which becomes x to the 1 divided by 1. Okay? But then we're not done, because then we have to evaluate them. This is a definite integral. So we have to do that from 0 to 1. And so what that means is you plug in 1 for all the x values, and then you subtract it from plugging 0 into all the x values. But the nice thing here is that 0 doesn't do anything, right? Because 0 will just make all these go away. So I only have to just plug in for 1. So this is easy. So this is just 2/6, which is just 1/3 minus 2 plus 1/3 plus 1/2 plus 2. 1/3 and 1/3 half. So what is that? 4/6 plus 3/6, 7/6. And you're good. Nice. Good question.
That's dope.
You're welcome, Nocturne. Cool. Good question.
Well done. Well done.
Okay, looks like a differential equation coming up next. Determine if the differential equation is exact, and if it is, solve it. Oh. You're very welcome, Nocturne. Thanks for coming by. Thanks for seeing the stream and stuff. I would stream tomorrow. I gotta go fly. One of my sisters getting married. I gotta go fly to Chicago tomorrow. So, No stream Thursday, no stream Sunday. Unfortunately, no stream Monday because I'm flying back. But afterwards, I'm here for a while, and we'll go back to our normal schedule of streaming 4 or 5 times a week. So, okay. How do you tell if a diffie-q equation is exact? What's that? Sorry, what is that? Oh, okay. The partial derivative with... Okay. Wait. I like this. Whatever. AI is like kind of helping me. Fine. This is where AI is useful because I'm not gonna ask it whether it is exact or not, but I'm gonna ask for the definition so I can solve it. Okay, so mxy dx plus nxy dy is equal to 0 if and only if the partial... Oh, okay, if dm dy is equal to dn dx. Okay, this is cool. So this right here, right? This is m. And this right here is n. Well, this minus part. Okay, cool. And then we're going to do dm dy. So I'm going to do d dy of cosine x cosine y plus 2x. I'm going to see if this is equal to d dx of negative sine x sine y minus 2y. Key thing here, this minus sign needed to get carried into each thing. So be careful about that, right? You gotta be careful about that. Okay, the derivative of this with respect to y. This is a constant because it has an x in it. This is called a partial derivative, which means I only look at y when I'm taking derivatives. So this is going to be negative cosine x sine y plus 0. Cool, great. And then the derivative of this with respect to x is going to be negative cosine x sine y. Nice. This looks like a foreign language. You'll get to this, dude. Don't worry, it's not that bad. This is differential equations, diffie-q. This is probably second year college, I would say. Maybe third. But anyways, cool. Check. So it is exact. If it's exact, is there a method for solving exact differential equations? Is there like a cool method? Is it like integrating factors? Do I gotta do integrating factors? Maybe it's integrating factors. How to solve. Find the potential function. Oh, bro. This is exactly like what we were doing in physics. Okay, integrate m with respect to x to find f. Differentiate f with respect to y. And then set it equal to n. You did? Very cool. Very cool, Instinct Boy. Yeah, Algebra 2 is like 90% of calculus anyways. I skipped pre-calc after Algebra 2 and I just felt like... Yeah. It's called pre-calc because you need the tools for it later. Okay, I want to see why this is, by the way. Sorry. So, I know d dy of m is equal to d dx of n. I want to see like why this works. Yeah, it is very helpful. I agree. So, oh, I see. I think I'm moving this over here, and I'm moving this over here. So I think I'm doing integral of m dx, which should equal the integral of... Wait, is the integral of... People are going to get mad at me if I do this. I think it's d dy integral of m dx is equal to integral of dn. Is that what's happening here? Because then I'm doing df dy, right? So they're saying this is f. And then I'm doing df dy. And set it equal to n. Right, cool, because the integral of dn is just n. Oh, that's fucking rad. And then we're going to check this to see if this works. Okay, but this is why it works. It's from this. Limp missile. What does limp missile mean? What? Okay. So, integrate m with respect to x. Okay, so m was that. So, integral of cosine x, cosine y plus 2x. Well, this is the only thing... Oh, sorry. Yeah, dx, by the way, right? Integrating this, this is going to become sine x cosine y plus x squared. And then what I need to do... And then, okay, and then this is plus some arbitrary function. Let's say like some g of y. Okay, cool. I agree. Because we only integrated with respect to dx. Okay. And then I take the derivative of this, because that's what this is, with respect to y. Okay. So then ddy of this okay is going to be equal to derivative of cosine's negative sine. So I get negative sine x cosine y plus x squared. That goes away. And then say I plus g prime of y. And then that equal to n, which n was equal to negative sine x. Oh wait, sorry, I fucked this up. This is negative sine x. Sorry, this is not negative sine x. Sorry. Integral of this is sine x sine y. I messed up. This is then equal to negative sine x sine y minus 2y. Okay, cool. What's the last step? What's the last step? I need this. From the previous step, you can find an expression for that and then integrate it to find that. Okay, fine. So, Abdullah says, your ability to go from really complex to the basics and explain everything thoroughly and clearly is honestly amazing. Wish more people you had at you. Yeah. Yeah, appreciate that, dude.
That's dope.
No, I think it is a really important skill, because a lot of, again, the reason why a lot of professors suck at colleges and universities is they're not hired to teach. They're hired to do research. And so they're very specialized. They're incredibly intelligent, but they're very focused on really like niche, high-end topics. And they've been focusing on them for so long, such that when they have to teach something that's like a basic class, I say basic, like an undergrad class to them, they just drop the ball because they're like, oh, this shit is trivial. And they've almost like forgotten how to explain it because that knowledge has already been assumed in order for them to do like the higher level stuff. Yeah. Oh, you did? Okay, cool. Thanks, Fem. I'm gonna check that out. Sorry. Let me just get this done. So this is 2 sine x sine y, or sorry, g prime of y is equal to minus 2 sine x sine y minus 2y. Okay, now we're going to integrate with respect to dy. So I got to do this dy. And so I feel like I'm going in circles here because I keep integrating and deriving by different things. So then this is negative 2, no, positive 2 sine x cosine y. What's up, Reiki? I do need to hydrate, thank you. Minus y squared is equal to gy. Okay, is that it? Am I done? Am I done at this point? Write the general solution. Substitute back into the expression for fxy. Oh, okay, cool. So then fxy was equal to this. Okay, cool. So, yeah. Okay, so you have sine x cosine y plus x squared plus 2 sine x cosine y minus y squared. But what's that equal to again? Sorry. Oh, is that just equal to 0? Oh, and it's equal to that is equal to c. 3 sine x cosine y minus x squared plus c equals... Let's see. I think... what's my PhD thesis? I did, here, if you want my thesis, I'll send it to you. This is my PhD thesis. If you want to learn about plasma turbulence, there you go. Very long page, paper thing I had to write. Okay, where'd we fuck up, fam? Fam, where'd we fuck up? Sleep schedule. I go to bed around 3 a.m. I wake up around 9 a.m. My usual sleep schedule. 9:30, 10ish.
Nice.
Yeah. Thanks for the follow, dude. Sorry, I want to see where I got this wrong. Okay, wait. You have to integrate m with respect to x. That got me sine x cosine y plus x squared plus g of y. Then I take a derivative of that with respect to y. That gets me sine x sine y plus g prime of y. And then I set that equal to minus sine x y minus 2y. Now I solve. So negative 2 sine x sine y minus 2y is equal to g prime of y. Integrate both sides. Where's the issue? Oh, integral of sine is negative cosine. That's fine. And then we plug that back in. Am I crazy, dude? I feel like I'm not. X squared minus y squared plus 3 sine xy. The basics? What type of basics? Like algebra? Let's see the definition. Let's see the thing that Fembox has. Fembox has a really nice... Oh, I like this. One sec. This is really cool. Like algebra, Jojo Mojo, or what? Okay. Sine xy ddx gets you cosine x cosine y plus 2x. Cool, I agree with that. And then this gets you... Oh, so were you just like literally looking at this? You were like seeing how can I get this to get this and this? Okay. I think I'm close. I have an extra one somewhere. I don't know where it is. Sine x sine y plus x squared minus y squared. So you did ddx, got you cosine x cosine y plus 2x. That got you minus sine x. Yeah, sine y minus 2y. And then we take the derivative again. Oh, they both equal negative cosine x sine y, which is what we got here. Yeah, okay, cool. Oh. I see. Oh, for sure, man, Abdullah. Yeah, I'm glad. Yeah, there should be a potential function. That's cool. Yeah, this is the potential function. Okay. Okay. This is the issue, right, Fembox? That this should be... This should just be... this should be a minus, and then this should be a plus. I'm confused, though, where you got that from. Because derivative... Oh, derivative cosine's negative sign.
That's dope.
Oh, man. Fuck. Okay. Figured it out. This is this. These go away. Thank you. gy is just negative 2y. Right? Yeah. This goes away. Yep. This goes away. Cool. So then it's just... It's just this. Cool. Yep. Okay. Y squared minus x squared minus sine x cosine y, which I think is what you had. Minus y squared plus x squared. Okay, yeah, same thing. Nice. Cool. All right, we did it. Yes. Nice. Love it. That was a difficult one.
Yeah.
Oh, man. Calista, thanks a lot. Purple face crying sorry for the No. I love this. Again. Never, I never hate the student. I hate the problem. But I shouldn't actually hate this problem. This is a really easy problem. Because, I hate that I couldn't do it faster, I guess is the one thing. Because, Femvox was able to just kind of like basically guess the solution, which a lot of times is what you do in differential equations. You say, I think the solution looks like this. You go test it, and if it does, you're like, great, it does. So yeah, Fembox says, great question. I agree, Callista. It's a great question. I'm just like mad at myself that it took me this long to get it. But that's okay. I hate myself into perfection. Some people say I should see a therapist for that, but I don't know. I liked it. I liked the struggle. Thank you, Callista. It was a really fun problem. Jack London says, hey guys, is math a field that I should study that will continue to provide good wages in the near future? I don't know. I mean, look at the history. Has math been a pretty profitable thing to study? Yes. I mean, it's not as profitable as, I don't know, like taking over countries for oil or like doing other weird shit. But yes, I would say being good at math opens up a lot of options for you to do many other things. So, for instance, if you're very good at doing math, then you're going to be very good at doing logical problem solving, which can be very useful for doing, I don't know, all sorts of things. You could become a quant at like a finance house and you could predict stocks, and that'll make you a ton of money. It'll also take your life away from you, but or you could go be an engineer, or I mean, you could even be a doctor. Like doctors have to think very logically sometimes to like be like dun, 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 you know. Engineering is math. Yes, exactly, Bully. It's all related. Let's see. Jinx.
My man.
Welding? Someone's got a welding question for me? Excuse me? Exactly. Yeah, the main purpose isn't to make money. If you want to go make money, you have to sell a bit of your soul. if your sole purpose is just to make money, it's usually at the expense of other people. Yeah, someone gave me a welding question. This is actually really cool. Whose question is this, by the way? Who asked me this? Anch. Thank you, Fembox. Wow, thanks for the dude. Thank you, bro. Thank you for the sub on Twitch. Revenue. We love revenue. Revenue's great. This is actually all part of a nonprofit. I help math and sorry, I don't help math. Sorry, I help middle school, high school students, college students as well, get excited about math and science and do well in it. And it's through like live streams like this that we help them. I'm glad you guys are finding us from YouTube. That's awesome. But yeah, we started this 4 years ago, creating a bunch of incentives for students to do well in their classes and then to also like play video games with them. So if you ever want to check out like what it's about, I should put a link to the nonprofit website, but it's also called Actual Education. There are links on my YouTube. You can go watch a video about like what we do. Okay. Oh, sorry. There have been some TikTok things. I can help with dynamics in physics too. I definitely can function base. If you put if you submit a screenshot to that website down there, I'll go through it. Is Calc 1 hard? No, I think Calc 1 is great. Honestly, I think Calculus is one of the easier math classes because it makes sense. Like there's a coherent story that's being told. In pre-calc, you're just learning a bunch of random shit. You're like, oh, sine is this. Oh, but e to the x is this. Oh, but logarithms are this. Oh, but like, because you're learning a bunch of skills and tools that don't really seem to connect. But then when you take calculus, everything you learn, like sequentially, builds upon the previous thing you learned, and you can see there's kind of a story to like why you're learning it. I love calculus. I think calculus is one of the coolest first math classes that you'll take. Yeah. Okay. I don't weld, so I don't know if I can do these questions, but thank you for submitting them. I always say there's no harm in asking. Like, please ask. And I'll see if I can get through it. But maybe I could do this. I could maybe do this question. This looks like a math codes. I don't know how to bead length. Exactly. Calc 1 is beautiful because everything you do is showing you why you do the next thing. 100%. Thank you, Brody, for submitting. I see your stuff too. Cool. Factoring. Yes. Okay, we're getting to yours soon. We're very close to it. Let me just see if I can do this one for Anch. Okay. Open circuit voltage, V naught is 90 volts. Short circuit current is 1200 amps. The voltage length characteristic of the arc is given by this, where L is the arc length in millimeters. Calculate the optimum arc length for obtaining maximum arc power. Wow. The voltage length characteristic. Yeah, this is so fun. Well, I know what power is, right? So power is equal to voltage times current. I smell derivatives. I think I do too, right? But how does that work with this, Zach, right? Again, all right. When all else fails, I'm going to throw this in the chat GPT, and we're going to learn from it together. Again, I'm not a welder. Although welding is a great trade, honestly, these days. If you're looking for something to make money, fucking welding. We need more welders, apparently. Here, I'm going to just ask it to... I'm going to do the quick one. Regular GPT-5 has been, like, so slow. Yo, what's up, Skeeg? Yeah, manufacturing is pretty cool. I think it's pretty dope, yeah. Long time no see. Nice. Oh, okay. Oh, this is a little bit more complicated than we thought it should be. Sorry, these are words I don't understand. Open circuit voltage. Oh, give the source resistance. But then terminal voltage. Yeah, no, there's too many specific things here. Okay, never mind. Okay, I'm going to pass on this question, but appreciate it. It was a cool one. All right, Brody. You're up. Exactly. Nicholas says, my father's kind of a welder. He works with metal. He knows zero algebra. What works, he knows works. Yeah, and that's very useful, honestly. We need more people that can weld. they call them like the trade sciences, like trade school. Like trade school is a great thing. I don't think everyone needs to go to college in order to be like successful in life. You can also learn a trade. Trades are very valuable, especially when AI is taking away a lot of the kind of white collar data entry jobs. I feel kind of bad for all these kids that got told, hey, just learn how to code and you'll get a nice cushy job, and now they can't find anything. Because if you only learned how to code and you didn't really learn anything outside of that, your job kind of got replaced. It is great to learn how to code. Everyone should learn how to code just because it teaches you a way of thinking, and you can also understand when AI makes mistakes writing code. But if your job was to just become a programmer, you're kind of shit out of luck right now. Okay, let's do question 1. This is the one you bombed. That's cool. I mean, it's not cool you bombed, but it's cool. That's the only one you need help with. Exactly. Right. Yeah. Okay, cool. All right, so off the ripper, I want to see if this goes into these things. I know I can divide everything by 2. Let's see if that helps. So, otherwise it's going to be like a bunch of weird factors. So, -6 plus, oh, yeah. Plus 57x minus 126, right? What should I study that will be bulletproof in the next decade? Don't answer what you like. I like almost everything. Yeah, no, I agree. No. You should be practical about like what you're studying. Like, just because you like underwater basket weaving doesn't mean you should go take out a $200,000 loan and learn it in college. Like, no, don't do that. No, don't do that. Coding is not dumb. Coding is still smart to learn for sure. I think anything medical is kind of bulletproof, honestly. Like being a nurse, learning any sort of like healthcare stuff. I mean, we're only getting more unhealthy if you add up all the microplastics and shit that we eat. So I think being in any sort of medical field is probably bulletproof. Can I divide this by 3? You are right? Oh, wow. Because 19 goes into this. Okay, let's pull a 3 out. -2x squared plus 19x. Okay, but wait a minute. Does 3 go into this? Oh, yeah. 3 times 40. It's 42. The answer's to life. 42 is the OG 6-7, by the way, guys. Y'all are all saying like 6-7, 6-7, or 21. 42. That's a number you should know. Okay. All right. Okay, so now I need to factor this. Okay. I'm going to do this times this. Well, first of all, I think I can factor... Let's factor out a -1 for starters, right? So I have -1, and this is 2x squared minus 19x plus 42. Okay. I'm going to see if anything easy factors. So I'm going to do this times this, which is 84. I'm going to see if any factors go to -19. And they both have to be negative at this point, right? In order to get to here. I don't think they do, right? Because what? I already see like -4 and -21. It's too high. Yes, it's kind of fucked. Okay. Oh, -7 and 12? Oh, you're right, actually. Oh, bless you, Femvox. Wait, does EnigmaBot still work? I'm trying to do it. Okay. Yeah, so watch. So we do this times this, Brody. That's 84, and I need factors of 84 that add up to -19. So I was kind of getting discouraged because I was like, oh, -4. So not 2 and 21. It's this times this, Brody. So you have to do 2 times 42, which gets you 84. And then you look at the factors of this. So you have -4 and -21. Pretty cool. This one works as well. It's kind of a more obscure one. Well, here, watch. Okay, so then you can do -8. Well, -8 doesn't work because this won't divide by 2. But -12 and -7 do. So notice that, like, this went up by 3, and then this went, like, down by 3. Yeah, look at that. Okay, cool, right? Okay. So now what I have is -1, and then this is going to be 2x squared, and then we're going to say minus 12x minus 7x plus 42. Okay? And now I want to try to group these things, okay? You want to see, like, what you can pull out of both of these things. So, I don't know if I want to show you this way or if I want to do it the other way. Yeah, let me show you a fun way to do it. This is actually kind of a cooler way. Watch. I call it the Punnett square method. Okay, so you're going to put this and this on the diagonals. So this is 2x squared. This is 42. You're going to put these on the off diagonals, which are these other diagonals. So this is minus 12x minus 7x, okay? And then what you're going to do is you're going to see what can I pull out of this whole thing, okay? Well, I know I can pull an x out. That's about it, okay? So I'm just going to pull out an x. Right? That's the only thing that goes into both of these things is x. So now I'm going to say, okay, well, this times what gets me 2x squared? That answer is 2x, okay? Now let's do this. What times what gets me minus 12x? Okay, well, that's minus 6. Then x times what gets me negative 7x? Okay, that's negative 7. And now I have my factors, which is going to be 2. And you should always check this last one. You see how, like, minus 6 and minus 7 both multiply to 42? So now I have my factors, 2x minus 7, x minus 6. And that came from this and this. And then there's also a minus 1 outside. Okay. So what the minus 1 does is it flips the order of one of these. Doesn't matter which one you do. I'm going to flip the second one. So 2x minus 7, 6 minus x. And there you go. That is the fully factored form. Does that make sense, Brody? Nice. Cool. Very welcome. Okay, let me ping Evoli. I'm gonna help Evoli out with stats before I gotta run out to my next student in 20 minutes. You've never seen the fact? Yeah, the Punnett. I think the Punnett square method is really cool. I don't know. I think this to me is easier than trying to factor this and factor this. Because here, if you want to see, like, why this happens, it kind of sucks. Don't forget the 6 I factored out at the start. Oh, thank you. Yeah. Ooh. I fucked up. Sorry. My bad. There's a minus 6 in this. Thank you, Santiago. Yes. Sorry, there's a 6 here. Yeah. Sorry, Brody. Yeah. Okay, Evoli, let me invite you to the stage. My bad. Sorry. There you go, Evoli, if you want to come say hi. Yeah. What's up, Evoli? Yeah. I'll wait for Evoli's microphone to work. She's like, unmute, mute, unmute. Sometimes you have to, like, leave the stage, come back to the stage. I think maybe if you've been here a while. Oh. Alright. There we go. Yeah.
Hello.
There we go. Nice. How's life? What are you working on?
I was working on more of those statistical for that there's those problems, and I'm pretty sure I got the other one for R wrong.
Okay. So let's see. We left off getting the R value, right, for this thing, which given the column Y and the column X here, right? you had to figure out like all these things like x, y, x squared, y squared, xy. And then we multiplied all the stuff, right? And then what we ended up getting, which is really cool here, we got an R value of minus 0.0537, which when I put that in the calculator is very close. They got minus 0.532. So showing that, like, yeah, if you did this on a calculator, so stat linear regression of L1, L2. Wait, sorry. Oh, wait, did it not save my lists? I'm going to be so mad if it didn't do it. One sec. Oh, it didn't save the lists. Oh, fuck. Okay. One sec. Let me put this back in because we're going to need these values anyways. It'll make life so much easier. To double check at least. What was the next thing we needed to do?
Y prime?
Oh, find y prime. Did we determine, is y prime the linear regression equation, by the way?
I don't know. I can go look in my notes.
Yeah, check it real quick while I put these data points in. 3522. Okay, and then this was 8567 9606.
For regression.
Sorry, say it again?
Yeah, it's for regression.
Cool. Alright, yeah, that's a linear regression equation. Okay, so they wanted to get the linear regression equation, which, funny enough, if you were to just go into the calculator here and tell it to do it, it gets it right away. So we're going to work towards this. I'm going to show you how to do it by hand. So what we're looking for eventually is this. Oh, sorry. Yeah. Oh, why did my calculator not show up? The hell? There it goes. Let me see. Oh, okay. I gotta fix that at some point. Okay. Okay, that's the equation we're eventually looking for. Okay? Which is going to be y is equal to negative 0.85x plus 1085. I'm going to say 10860, because that's what this like rounds up to basically. And this is y prime. But let's see how to do it by hand. That's how to get R. How do you do a least squares regression? How do you get this? How do you get the slope? Least squares regression equation.
If you had time, I'd like it if you'd look over that one that I got wrong. Or at least I think I got wrong.
Which one did you get wrong?
The next one I was working on, just the R.
Okay. Let me go look at it for a second.
I already have the answers laid out and everything, so should be easy.
Okay. Let me see. I don't know why this isn't loading. All right. Sorry. Remind me again, Evil. Where's the one you got wrong?
It's not in what I sent you. It's just when I was working on doing other stuff, and I think I got it wrong.
Okay. Did you submit it somewhere, or you're gonna send it to me later? Sorry, my brain's frazzled right now.
If you have time.
If I have time. Okay, cool. Which one's more important? Which one's more important for you? For me to teach you like manually how to do least squares regression, or to explain like where you got something wrong?
Definitely this, because I still don't know how to do this even.
Okay, that's okay. Cool. It's fine. Okay. Here we go. Okay. That's that. Wait. That's how to find B. Where do you get the... Sorry, where do you get A? Yeah, where do you get A from? Where the fuck is A from? The final step is to calculate the intercept, which we can do using the initial regression equation with the values of test score and test met as their respective means. Oh, that's so cool. Are you married, Mr. Mauger?
I have.
No.
If you're looking for how to get A and B, I have it in my notes.
I think I have this. I think this is what we have. Yeah. Okay, here we go. All right. I think this is what we want. Here, let me clear this page. I'm gonna put this here. This is what we're looking for. And then this is what I want. I want all this. Good. Yeah. Okay. Let's try to interpret what this is. So B is the slope for my linear regression line. Okay. Which is going to be nice. Oh, okay. And this is what they give you? Yeah, that's wait, what?
I'm getting stuck.
Oh.
I think I might have to close my Discord because for some reason.
What's getting stuck?
Wait, no, there it is. Okay, I have the word button. My Discord is being buggy.
Oh, okay. Oh, this. Oh, sorry. Okay.
I might have to close it. Real quick.
Okay. Ah, it's the numerator in R divided by the x part of the numerator of R. Oh, so you don't really have to do anything else. That's really cool, actually. Here, okay, so let's go to here. This is statistics, is what this is. Very cool. Uh-huh. Yeah, so this is the same as this, which is the same as this. Very cool. And then this part right here is just this part right here, which is just this part right here. Okay, very cool. So, oh, we can get this like right away. This is actually really cool. So B equals this. And then I think just without the squaring. No, you do have the squaring. Always has been. Dude, yeah, I love that meme. That's one of my favorite memes, dude. Okay. So, 1.31 e to the 8th minus 222 times 37240 divided by 5. And then we're going to divide that by, in parentheses, 1.01. Oh, yeah. E to the 8th minus 200 and then a 22 squared divided by 5. Minus 0.87. Oh, very cool. That's very close to what they got. They got minus 0.85. Okay, cool. I'll take it. Minus 0.87. And then, yes, to get A. So now you know that y hat. Or do they do this? Is it? No. How do they write it? Sorry. Yeah, they say y bar. Y bar equals x bar. Interesting, they call this one B. mine calls it A. This is swapped. Which, okay, you can tell the calculator to actually do the different lin reg. You can say calculate lin reg A plus BX. There we go. That'll make things happier. Okay. Y bar equals, and then this is going to be B, or it's A plus BX bar. Where this is the average value of Y, this is the average value of X. If you want to get the average value of X, you can do that here. So X bar is equal to adding up all the X values and then dividing by how many you have. So that's this divided by 5. So let's do that. 22 divided by 5. So that's going to be 4004. And let me put this in a different color. $7,448. $4,004.4 and then 7,448. Okay, so 7,448 is equal to A plus negative 0.87, 4,004.4. So then we solve for this, which is just that plus 0.87 times 4,004. Nice. And we get that A is equal to 10,931. I'm going to say 10,932. Which they got 10,859. Whatever. Close enough. Okay. Evo, is your mic working? I don't hear you. Uh-oh. Discord having issues today. Let's see. Yeah, let me move you to the audience. Let me bring you back up the stage. Maybe that fixes it. Test? No? Maybe restart Discord, Evoli? Yeah, this is stats for sure. Dude, you talk to those variables. They listen, dude, right? Okay. Okay. There we go.
I can see mine lighting up.
Yeah, I can see yours now. Yeah, I don't know. Maybe it's just because I've been streaming for so long. Okay. Did you understand what I did there?
I believe so.
Okay, cool. Right? Yeah, I mean, this is this part that we already had from R, and then this is just this part which we had from R. So we got B, which is like the slope. And then in order to figure out the constant, you take the average Y for Y hat, you take the average X for X hat, and then you solve for A. And this is your Y-intercept. Okay? So your final equation, Y prime of, what is it? Let's just say Y prime of X is equal to 10,932 minus 0.87 X. Okay? Which is pretty close to what they got. And then, do you know what it means when they ask you to predict when X equals 9,000? What do they want you to do with that?
No. I have no clue what to do there.
Okay, they just want to know this. Y prime of 9,000. Because what this does, Evoli, this guesses what Y is, which is, I think we said Y was the debt, right? Yeah. So, Y is the debt. X is the tax. So when the tax is 9,000, I want to know what does the regression line predict that the debt will be. Notice how here I don't ever have 9,000, right?
Yeah.
Okay. So all you have to do is plug this into your regression equation, and that will predict it for you. That will predict what the debt would be, what y would be. Oh, you typed in some... Yeah.
Times the y, and then it gives you your answer.
Yeah, so you negative 0.87 times 9,000 plus 10,932, and that equals 3,102. Does that make sense? 3,102? Yeah, because I think the debt goes down as the tax goes up. If you wanted to see this on the calculator as like a stat plot, remember we did stat plot here. I
actually made a stat plot for it.
Cool.
Already.
Do you see how it's like kind of trending down, right?
Yeah.
Yeah. So if I do zoom stat here, right? Yeah, this is my graph. So this should kind of show that, yeah, as it looks like it's trending downwards. So as we tax people more, our debt goes down. Yeah. Cool. Nice.
Do you have time for that question or no?
I do. Send it to me right now. I'll do it. I have, like 5, 6, 7 minutes. I see this question, Santiago, that you sent.
Okay.
I don't know, Santiago, if I'll have time for this one. But if you come by the next stream, I'll help you with it. This is cool, though. It looks like you're doing chromatography and stuff. It looks like a lab report, honestly. Also, like, what's the question on this one? Oh, it says, oh, this is stats. Oh, this is cool. Okay, cool. Yeah, all right. Let me see what Evoli sends me, though, first.
I will just send it. Sorry, I'm just screenshotting.
Okay. Evoli spelled backwards is I love. Oh, you love ravioli. You love ravioli. Is that what it is?
It is? I didn't even realize that. That's funny.
Evoli I didn't realize it either, and like you've been on my server for a while. What? I never realized your name was I love ravioli.
Reference. So.
I love ravioli. I love ravioli too. Big fan of ravioli. Okay, let's see this question.
Wait. I'll be right back. My Discord is bugging again.
Okay.
Oh my gosh.
All good. My everything is bugging right now actually, because fucking OBS 12 screwed everything up. There we go. Okay, good. All right. Says the data shows. I do help people with all kinds of math. We've been doing a lot of different types of math here at Pinhead. Here, let me move you back to the audience. Move you back up. Yeah, I still don't see anything. I think you just have to like keep resetting it. Sum of x. Let's see if it works.
Hello?
Hello.
Okay.
Okay. All right, so let's see. Let's see.
R has a face next to it.
Nice.
Oh, the sad face? Oh, for calculating R? Oh, yeah, because there's a lot of steps. There's a lot of missing steps there, Evoli. Right? Just because you have... You still have to take... You still have to take all these fucking numbers and put it into this massive-ass equation.
I did that already. I just did it in my head. And, like, on the calculator.
No, Evoli, I'm sorry, no. Okay, Evoli, especially when like
it's a pain to write out though.
Bro, when this is the equation, you're gonna mess something up. I know, it's a huge bitch. All right, I'm just gonna check to see if your numbers are right for like here, and then we can just assume it's a calculator error.
Okay.
Okay.
I did down there the negative 1.56 is the top one, and then the 7.52 is the left one, and the 22 is the right.
I see. I see. That's like the part that it is. Okay.
Yeah.
Okay, so first of all, automobiles and light commercial vehicles. So wait, which one's X, which one's Y?
The Y is the 12.8. Oh, X is on the top for some reason. Y is on the bottom.
I think that makes
I
sense. Yeah, so for the number of automobiles, how many commercial vehicles are there, right? Okay. So that's, okay, 7.8, 4.2, 1.2.
Oh, I did want to ask to make sure that you, for the previous one,
Yeah.
that you did put X on the top and Y on the bottom.
That's a good question. Where did we do it? No, I put Y on the top, X on the bottom.
Oh yeah, because if you zoom in, I think it says, yeah, it's supposed to be X on the top and Y on the bottom.
Is that real? Is it always like that?
I think so. It was like that once, and then I just kind of assumed it continued to be like that.
No, I don't think you can assume that. I don't think you can.
Well, let me find it, because it says on the thing.
You have to kind of ask yourself what's the independent variable and what's the dependent variable, right? In my experience here with the government, they usually vary the tax, and that changes the debt.
Yeah, no, it's X on the top, Y on the bottom.
That makes no sense.
That's what it says in the textbook. I can send the screenshot.
Chat. Do we think debt is independent and tax is dependent? I don't think so.
Let me send it in the... I'm not going to send it in the... I don't know.
okay.
I can't send it in the VC chat or else I'm going to get glitched out again.
Oh, don't worry.
know why.
I'll trust you. Okay, whatever. I'll trust you. It's fine.
Let me...
No. I believe you. I just think that's wrong.
Oh my god, I did glitch out again. That's a bad idea.
No, don't glitch it. Don't glitch out.
I did glitch out.
This makes sense to me. No, don't worry about it. Don't worry about it. I trust you. It's okay. This to me makes sense. Like, the number of automobiles should determine the number of commercial vehicles, I would think. Okay. So I'm putting these variables in just into lists real quick here.
Yeah, sorry, let me reset my Discord because now I'm
Okay,
sad
go
that it's
reset your
messing up
Discord.
again.
It's okay. Go reset. You're good. And then I think L3 is going to be x squared. So we're going to do L1 squared implies L3. And then we're going to say that L2 squared implies L4. And then we're going to say that L1 times L2, so XY, is going to imply L5. Nice. Because I think that's how you do this. I don't want to go all the way back. Yes, because we have X, Y, X squared, XY. Cool. Okay. Cool. So here's the cool thing. I can just go into stats here. And let's just do a quick... Oh wait, I gotta turn diagnostics on. Remember this. This is like a weird thing you gotta do in the calculator. In order for it to give you an R value, you have to tell the TI to do diagnostics on. Here, let me move you to the audience, you bully. Try it again. Or here, sign out. You get out of the stage and then come back. It'll fix itself. Okay. Thank you. Okay. Yeah. Good.
Yeah, I could hear you in talking before. It just kicked me out for some reason.
But I can't hear you.
No, I wasn't talking.
Oh, you weren't talking. Oh, my bad. Whatever. I just skipped you. It's like fuck. Okay. So here, if we do the lin reg on L1, L2, this is cool. There you go. That's what it should be. Your R should have been 0.09. Negative 0.09.
Yeah, that's what I assumed because that's what GPT said. And yeah. I was like, I must be messing up here.
Okay. So let's look at what your numbers are real quick, right? So sum xy is... Oh, okay. Yeah, let's check your numbers. Let me check your numbers right here. So sum xy was L5. So, sorry, list, math, sum L5. So L5 stored the xy. That should have been 35.7.
Okay.
Sum of L1 should have been 15. I agree with that. Cool. Sum of L2, 12.8. I agree with that. Sum of L1 squared. So that this should have been x squared. 82.52. That's okay. And then sum of L4. Yeah, okay. These are all okay, Evoli. Except I think this one should be 35.7. Okay. So then you have 35.7, right? Minus 15 times 12.8 divided by... How many n's do you have? 4? No, 5. So negative 2.7 I got on the top. You got negative 1.56.
There.
Yeah. Right, 15. Okay, so... this should have been negative 2.7. Alright, then let's do the other one. So sum of x squared, so that's the 82.52. Minus 15 squared, which is just, yeah, 225. Divided by 5. So, okay, but then you need the square root of that. Or no, you're going to do the square root of them probably at the end, right? So this should have been 37.52. And then sum of y squared was 55.34 minus 12.8 squared divided by 5, which is 22.5. I agree with this one. This one's okay. Okay. So now if you do this times this and you square root it, you get that. And then you're going to do negative 2.7 divided by that answer. And that gets you an R of minus 0.09277, which is exactly what's here. Nice. That's cool, no? So yeah, you had an error on this one for sure. And then this one was off as well because you were off with this. All good. Okay, I gotta run. But did that help you out? Yeah?
Yeah, thank you. I gotta redo the first one.
You got it. Just, it's the same thing. You'll get it. All right, cool. Let's close out the stream. All right, thank you, everyone.
That's great.
For coming to Actual Education Office Hours. Appreciate all the questions, everything. Really fun. Thank you. Yeah, what was the error? It was just a little calculator error. Anyways, thank you everyone for coming by. If you want to figure out when we're streaming, again, we have a website for that. It's the submit.actual.education. You can click our streaming schedule here and see the next time we're streaming. Which, for me, I don't think will be until Tuesday next week, unfortunately. But to hold you guys over, Zach will be streaming on Friday. He's doing a cool math trivia night, and then he's also doing a stream on Saturday. So please go out, support, have fun with him as well. Okay, so we're going to go raid someone on Twitch. So yeah, if you're watching us on Twitch, also, if you want to follow us on all the different platforms, because sometimes Twitch is easier to watch because it's horizontal. YouTube, we do vertical because YouTube horizontal just doesn't get the algorithm happy. You can also join our Discord if you want to talk with us and hang out in the community and, I don't know, get more help when I'm not around. So, let me go raid a channel so that Snazzy and Femvox can still talk to each other. I appreciate you guys talking. That's awesome. I love when my chat rooms become like places of meeting of intellectuals. You're all intellectuals if you're watching this. Congrats on not scrolling through to the brain rot. No. Oh, we're gonna go raid. Yeah, I love this person. Ask a Scientist Gaming. I love these people. So this is a really cool streamer. He's a professor at University of Florida, and he interviews other professors about just general topics while they play video games. So very cool. Yeah, thank you, Fembox. Thanks for all the help. Okay. Enjoy the rest of your week. We will see you next week. Peace.